In the last class, I already discussed with you the Realloc function and Malloc function. These two functions are basically used for the purpose of dynamic memory allocation. What is dynamic memory allocation? That also I discussed in the last class. In the case of normal declaration, the memory allocation done at the time of compilation. But when we try to allocate memory at the runtime, we need to take help of these functions, whether Realloc and Malloc. And already discussed about the free function. We know what is the purpose of free function. This basically deallocates the memory which is allocated by some dynamic memory allocation function. Only one function left to discuss, that is the function realloc. What this realloc function does, suppose consider a situation you have allocated memory for some integers, say 5 integers. After some point of time, whether after some execution line over, you think that this 5 integer is not enough for your program. 5 integer is not enough for your program. You want to allocate, whether you require more memory to store more number of integers or to store more data. So this kind of situation may arise. Try to understand. Consider a situation. First, you have allocated memory for n integers or for n numbers. After some point of time, you need to allocate more memory, rather for more, you need to allocate more memory for more numbers or more integers. As you are considering only integers number, so I consider you need to store more integers number to store. So what you will do? Again, you have to allocate memory for that more numbers, or rather more integers. Suppose you require 2 more integers. You have allocated memory for 5 integers. After some point of time, you require 2 more integers to allocate. What you will do? You can allocate memory. You can allocate memory for that 2 integers by using Realloc and Malloc function once again. Fine. But that will be that is not a good solution. Why that is not a good solution? Because if you allocate the memory using Realloc and Malloc again, it will not be contiguous with the previous element. Will not be contiguous with the previous element. That means you already allocated memory for 5 integers. Say starting address of those 5 integers is say 5020. For first integer it is 5020. Next will be 5024. Next will be 5028. Next will be 5032, and next will be 5036. Fine. So in this way, memory gets allocated. 5 integers, so 20, 24, 28, 3236. So in this way, the memory allocated for 5 integers. Now, if you allocate memory for 2 more integers using Calloc or Malloc function, the address of the 6th element, 6th and 7th will be the new one. The address of 6th and 7th element will not be 5040. Maybe 5040, may not be 5040. There is a chances that the memory allocation for the new integers, as because we considered integer elements, the memory allocation for the new integers or the new element will not be contiguous with the previous one. So that is the limitation for the newly allocated memory if required in your program. So to solve this type of problem, so this is a problem because we want to allocate memory for elements in contiguous fashion. But if we do it at the same time, we get contiguous memory. But if we try to do it in the different execution, the memory allocation may not be contiguous. So to overcome this situation or overcome this problem, we need to take help of this function named realloc. Full form is reallocation. So going back to the slide, what reallocation function does, let me share the slide. Look, the first point says realloc deallocates the old object pointed to by PTR and returns a pointer to a new object that has the size specified by size. Second point, the contents of the new object is identical to that of the old object prior to deallocation, up to the lesser of the new and old sizes. Third point, any byte in the new object beyond the size of the old object have indeterminate values. And the last point, the point to note that the realloc should only be used for dynamically allocated memory. If the memory allocation is not dynamically allocated, then the behavior is undefined. I am explaining one by one. So first try to understand what is the syntax of this realloc function. Why we use realloc function, that I already explained just. Realloc function is required when you already allocated memory for some elements by using Calloc or Malloc function. You required to allocate more memory. So at that point, if you use Calloc or Malloc function, the memory allocation will not be contiguous with the previous one. So that's why we require another function like realloc, which will allocate memory contiguous with the previous allocation. In this situation, we are calling this function realloc. So try to understand this example. Already it is showing in the slide. First, I have allocated memory for 5 integers using malloc function that I already discussed with you. Malloc function, if successfully allocates the memory, what it takes as a parameter, it takes total amount of byte to allocate. So here 5 into size of int, that means size of int if you consider 4, 5 into 4, 20 bytes it take as a parameter, and this malloc function allocates memory 20 bytes and it returns the starting address if the memory allocation is successful. That much is discussed in the last class. Now, next line, what I am doing, look, I am calling the realloc function. So I have already allocated memory for 5 integers here. So this is the pictorial representation of this. A large 20 bytes memory block is dynamically allocated to PTR. Nice. Next line, realloc. What it takes? 2 parameters it takes. First one is the PTR itself. What is this? PTR is the pointer that is actually points to the previously allocated memory. Previously allocated memory, that allocation done by malloc or calloc function. So PTR is the pointer which is storing the address of the newly allocated memory that is done by calloc function or malloc function. That PTR needs to pass as a first parameter of the realloc function. Try to understand. What is the first parameter of the realloc function? The first parameter of the realloc function is the pointer. Which pointer? The pointer that stores the address of already allocated memory that is done by malloc function or calloc function. And what is the second parameter? The second parameter is total amount of bytes. What is the meaning of this total amount of byte? Sorry, just a minute. What is the meaning of this total amount of byte? The meaning of this total amount of byte is not only the newly allocated memory, it is the memory required for new elements, memory required for the new elements, as well as the memory already allocated. So here we try to allocate memory for 5 more integers, and we already allocated memory for 5 integers. In this line we already allocated memory for 5 integers. Now we are going to allocate memory for 5 more integers. So that's why the second parameter here is 10 into. 10 means not newly 10, newly 5 elements and previous 5 elements. So it takes total amount of bytes for how many bytes it will allocate the memory. So it will take 10 into size of int. That means 10 into 4, that means 40 bytes. So this size PTR is changed from 20 bytes to 40 bytes dynamically. So try to understand. I'm once again repeating what realloc function takes as a parameter. First parameter is the PTR. What is the meaning of this PTR? This PTR is the pointer variable which stores the address of already allocated memory done by calloc function or malloc function. That means which is done by dynamic memory allocation. So that PTR you needs to pass as a first parameter, and second parameter is total memory allocation byte. Total means previous plus new. Previously I have allocated 5 integers and newly I want to allocate 5 more integers. So that's why I have passed here 10 into size of int. So now 20 becomes 40. Fine. I hope syntax of realloc function is clear to you. Now my question is how it works. That thing is defined in my previous slide. How it works? It basically deallocates the old object pointed to by ptr. That means the allocation already done by the memory allocation function, either calloc or malloc, whatever the function you have used, that allocated memory gets deallocated first. So realloc function deallocates the old object pointed to by ptr, fine, and returns a pointer to a new object that has the size of specified by size. So what it does, it basically deallocates the previous memory and it will newly allocate the memory for previous number plus new number of elements. So that's why it is written. Realloc deallocates the old object. So it deallocates the previous memory location. Which memory location? That is pointed by ptr. ptr you have passed as a first parameter of the realloc function. Try to understand. And what it returns? It returns a pointer. Again, it returns a pointer. Definitely a white pointer, because we already know this calloc function, malloc function, same realloc function. It returns white pointer if it successfully allocates the memory. So it returns a pointer to a new object. What this new object consists? The new object is actually consists the newly allocated memory size. What this newly allocated memory size? Newly allocated memory size is the previous number of element plus new number of elements that you want to allocate. That means here in our example, this is memory allocation for 10 integers, 5 previous and newly 5. So a chunk of memory gets allocated for 10 integers. And one more thing it does. What it does, it basically copies the previous element to the newly allocated memory. So that means you may think that when the previously allocated memory gets deallocated, that means element get lost. Elements at that location gets lost. That is the situation. Now, no, when realloc function allocates memory newly for existing element and the new number of elements. So at the same time, what it does, it just copied the previous elements to the new memory location. So the previous elements will never be get lost. So that is also mentioned. The contents, look, second point, the contents of the new object is identical to that of the old object prior to deallocation. So prior to deallocation, the elements of the old object will be same to the contents of the new object. New object means newly allocated memory, up to lesser of the new and old sizes. Up to lesser of the new and old sizes. Try to understand the meaning of this line also. Up to lesser of the new and old sizes. I consider a situation, rather here, I consider a situation where I am expanding my memory space. Fine. Expanding my memory space means we have already 5 integers. We want to expand it to 10 integers. That is the scenario I consider in my program. Suppose if the scenario is reverse, means you have 5 integers, you want to shrink it. Matlab you have to minimize it. So that means what is the case? You already have allocated 5 integers. You have taken 5 inputs from the user. Now you want to shrink the size. So if that is the case, that's why this point is mentioned. Up to the lesser of the new and old sizes. Lesser means which one is the lesser? Maybe the new size is lesser, maybe the old size is lesser. So that's why it is mentioned up to the lesser of the new and old sizes. So if you shrink your size, that means you must be lost the extra already allocated, already inputted data in the previous memory allocation. Again, I am explaining this point. Suppose you already allocated integers for 5 numbers. So you have taken input 11, 22, 33, 44, 55. Now you want to resize it. You try to resize it by using Realloc function from 5 to 2. So what will happen? Definitely 11 and 22 will be there. Rest 33, 44, 55 get lost. So, and if the situation is reverse, that means you have 5 elements, you want to allocate 2 more, 5 to 7. Then what will happen? 11, 22, 33, 44, 55 gets copied, and you will get 2 more spaces to enter 2 more new elements. So if the size up to the, that's why it is mentioned up to the lesser of the new and old size. Which one is lesser? That depending upon the situation, it may be the previous one, it may be the new one. So up to the lesser of the new and old sizes, the contents of the new object is identical. The content of the new object will be identical up to how much? The lesser of the new and old sizes. Maybe the new size is lesser, maybe the old size is lesser. Fine. Next point. Any bytes in the new object beyond the size of old object have indeterminate values. That means you are trying to allocate 2 more integers. So you have allocated previously 5, now you have allocated 7. So how many elements are beyond the size of the old object? 2. How many elements are beyond the size of old object? 2, because I have already allocated memory by memory using malloc function for 5 integers. Now I have allocated 7 integers for using realloc function. So 2 elements are the beyond the size of old object, which are throwing indeterminate values. That means garbage value. Initially, the newly allocated memory space consists garbage value. That is the point. And the last point, the point to note, so very important, is that realloc should only be used for dynamically allocated memory. If the memory is not dynamically allocated, then the behavior is undefined. Suppose you have allocated memory for 5 integers by declaring an array. Fine. We already know the array name itself will behave like a pointer because it stores the starting address of an array. So what you will do, you will have consider one more pointer variable, and you are writing star ptr equal to arr. So that means ptr is now pointing to your array. So you have allocated memory 5 integers, not by using calloc or malloc function. Try to understand. You have just, that is not the dynamic memory allocation, that is static memory allocation, which is done at the time of compilation. The last class I discussed, if we declare an array of size 5, so 5 into 4, 20 bytes memory allocation process done at the time of compilation, not at the runtime. So you have allocated memory for 5 integers, not by using any dynamic memory allocation method. Now you are trying to expand that 5 integers to 7 or 10. Can you do it? Answer is no. The behavior is undefined. You cannot define it. You cannot surely say that this will work. This may not be work, because realloc function can only be used. That is the point. Realloc function can only be used if you dynamically allocated memory, if you use dynamically allocated memory, that means already you have allocated memory by using some dynamic memory allocation method, either Realloc or malloc. So Realloc function and malloc function is used for dynamically allocated some memory. Say for 5 integers I have allocated memory at the runtime. Now at some point of time it requires 5 more integers or 2 more integers in your program. So then we will use this realloc function. And what realloc function takes as a parameter? It takes 2 parameters. First parameter is the pointer itself. Which pointer? Let me share the screen once again. Which pointer? The pointer that is already used for the memory allocation purpose previously. Here PTR. PTR basically stores the address of already allocated memory. PTR is already stored the address of already allocated memory, which is done by using malloc function or realloc function. Now this PTR will be passed as a first parameter of the realloc function. And what is the second parameter? The second parameter is the total byte. Total byte means previously allocated memory plus newly allocated memory. I try to allocate memory for 5 more integers, and previously I have allocated 5 integers. So that means we have to pass the size for 10 integers. So 10 means not newly 10. 10 means previous 5 and new 5. Fine. So 10 into size of each. So it will allocate memory for 40 bytes. So it changed from 20 bytes to 40 bytes. Next question is how it will allocate the memory. Answer is, that is your doubt, answer is it basically deallocates the previous memory. Fine. So that means previously allocated 20 bytes gets deallocated. Again, it will allocate memory for 40 bytes. And the data that already stored in that 20 bytes memory is just copied in the newly allocated memory, that is 40 bytes. So that means if you consider this situation, you have 5 elements, 11, 22, 33, 44, 55. Now you have allocated 10 integers. Fine. So that means that 5 integers allocated memory get deallocated, and allocated memory for 10 integers, and that 5 integers that already you have in the previous memory allocation, before deallocation it gets copied to the new memory. So that means you will not lose the previous data set that you have already in the previously allocated memory. So what this point says, again I am repeating, realloc deallocates the old object. Object means the memory space pointed to by PTR. PTR is the pointer that is pointing that memory space rather than that object. So the realloc deallocates the old object pointed to by PTR and returns a pointer to a new object that has the size specified by the size. Specified by the size is the second parameter. Specified by the size is the second parameter of the realloc function. So it allocates the new object that I mentioned, and what it returns a pointer. What that pointer says, again the starting address. The starting address will not change. It will remain same as previous, but the memory allocation length will be different than previous. Previously it was 5, now it gets 10. Third point, any bytes in the new object beyond the size of the old object have indeterminate values. Yes, you have 5 integers already. So when you are allocating memory for 5 plus 2, say 7 integers, you have the 5 elements with you. 11, 22, 33, 44, 55, these elements you have already with you. But for the rest of the 2 memory spaces, if you allocate any elements, not allocate any values to that newly allocated memory space, then if you check the initial value of that 2 spaces, you will get indeterminate values. That means the garbage value. I will show you in this example. When I am writing a code, I will show you how this is happening. Any confusion up to this? This is the memory allocation part that is already done by in the last class by using malloc function. This malloc n into size of int. So I am trying to allocate memory for n integers initially, and I am taking input for n integers just like previous example. I equal to 0 to I less than n, I plus plus, it is scanf %d comma ptr plus I. Fine. Start. So this part is already discussed with you. So just I'm showing the output of this part. Just a minute. So this much is fine because we already knows how it works. Now I'm considering the value of n is 5, which is taken from the user. Now I try to allocate some value at the position star ptr plus 5 equal to 35. Fine. What is the meaning of this? The meaning of this line is actually, it is equivalent to, if you write it the equivalent statement of this, that means ptr 5 equal to 35, right? So what is the meaning of ptr 5? The meaning of ptr 5 is sixth element. 0, the index starts from 0, so ptr plus 0 is the first element, so ptr plus 5 means sixth element. I have allocated memory for 5 integers. If I comment this to line and if I set the value of n equal to 5, so value of n equal to 5, that means I am trying to allocate memory for 5 integers, and now I allocate some value to add index 6. Will it work? Will it work? If you execute or rather run this program in the GCC compiler, purely GCC compiler, that means in Linux environment, this program will give you a compilation error. Why? Because you already mentioned n equal to 5 and you are trying to assign some value at which index? Index number 5, that is the sixth element. So in reality, if you think about it, it should not be executed. Fine. But if you run this program in this environment or in Turbo C environment, you will look that the program executes fine. Why? There is another reason. That's why the program executes fine. Because the boundary checking of an array is not defined in this compiler. Boundary checking of this array means if you declared an array size 10, what is your boundary? 0 to 9. If you try to assign some value at index 10, it shouldn't be assigned. Rather, it needs to give an error because the memory allocation at index 10 is not done according to the declaration of an array. But in this environment, there is depth C as well as in Turbo C, the boundary checking is not available. That's because this will work fine. And if you print the 6 elements, you will get 6 elements. But memory allocation you haven't done. So that is the wrong thing, which is actually executing over here. But the correct theoretical concept, if you implement the theoretical concept, this is illegal. PTR plus 5 is not legal for this case, as because you allocated memory for 5 integers. You try to assign some value for the index 6, for the sixth element. The memory allocation of the sixth element you haven't done. So that's why this statement is basically illegal for this case. So now what you have to do? You have to reallocate memory. This is the situation where we require reallocation. So now we are trying to reallocate memory for this purpose. So what is the syntax of the reallocation? The syntax of the reallocation is realloc, just syn. First pointer is the PTR that stored the previous address, and the second one is suppose I want to expand the memory for two more integers, n equal to n plus 2. So your new n value is n equal to n plus 2. Fine. So realloc PTR, comma, n into size of int. Fine. What it returns? Again, void pointer. So n star, and that should be stored inside PTR. You may take another pointer also, because the previous memory allocation is deallocated, gets deallocated. So there is no existence of PTR after this realloc operation. So you can reuse that PTR. Now check the previous PTR value and newly allocated PTR value. Printf /n PTR equal to %u, comma PTR. This is the previous PTR, and I am printing the same line here also once again. Fine. I am just commenting this line because this line is illegal in this case. You haven't allocated memory for this index. Fine. Now what I am doing next? Now my n value is 5. Now I am just copying this line here. Star PTR 5. Say make it 100. Fine. And star PTR plus 6, rather PTR 6. That is the same syntax. PTR 6 equal to 200. These two are basically same. Star PTR plus 5, we can write it as PTR 5. Similarly, PTR 6 I have just written in this manner. Fine. Now what I am doing, I am just printing the value of this here. N becomes 5 to 7. So naturally 0 to 6 it will iterate, and it will print the value of the newly allocated memory, rather newly assigned memory. First I am omitting this two line so that I can show you initially the value was garbage. Fine. I am not assigning any value to the two vacant spaces. When I am going to allocate memory for 7 spaces, n becomes 7. So I am going to allocate memory, newly allocate memory 7 spaces, 5 gets copied, 2 vacant. I try to print the value of these 2 vacant spaces, you will get garbage value. Let me show you the output of this program. Let me share. Look, this is the PTR value. Matlab, when we have done the memory allocation by using malloc function. This is the starting address of these 5 integers. Now I am putting the value 11, 22, 33, 44, 55, 5 integers. Look. Look, here the PTR, gets changed. Here the PTR gets changed, but some point of time you may look that value of PTR may remain same. That completely depends upon the operating system. Memory allocation, previous memory allocation will be deallocated, but newly allocated memory may be same, may not be same in all the cases. Here memory allocation starting address gets changed. Look, so I have given the input 11, 22, 33, 44, 55. This is the first output set. Then I print the newly allocated memory address. It gives us the different address. So 7 memory allocation done. 5 getting from the previous. These two are the garbage values. These two are the garbage values because I haven't assigned any value to the newly allocated memory space. So look, now I am assigning new value to the index 5 and index 6. Again I am execute evening. Putting the value 11, 22, 33, 44, 55. Look, 11, 22, 33, 44, 55. New value I have already given, that is 100, 200. Now this garbage value gets overwritten by these new two values. Fine. One more thing I haven't used over here, that is the free function. As because the memory allocation done by using dynamically, so I need to free this memory. So free PTR I have to write. Lastly, that is similar to the previous program. One more point I must discuss over here. Instead of free PTR, I may write realloc PTR, 0. Can you explain this? This line is similar to the previous, rather it is equivalent to the free PTR. The answer is yes, this line is equivalent to the free PTR. Why? Because I already discussed with you how realloc function works. The realloc function basically deallocates the previous memory, and the second parameter is you have to pass the total number of bytes that it again allocates memory for this purpose. Previously allocated plus newly allocated amount, both you have to pass. So where I am telling the memory allocation, newly allocated, reallocated memory amount is 0 byte. So what it does basically, it destroys the previous memory, it deallocates the previous memory, and newly allocated memory is 0 byte. Newly allocated memory is 0 byte because I have passed the second parameter as 0. So definitely it must be equivalent to the free PTR. So free PTR statement is equivalent to the realloc PTR, 0 as because realloc function, the working principle of realloc function is it deallocates the memory first and again it allocates the memory for previously allocated elements and newly allocated elements. So I hope this much is clear to you. If you have, so as I explained, the memory allocation process is done by the compiler and the operating system. So that's why sometimes the memory address of the newly allocated memory, that is done by realloc function, remains same with the previous starting address, and sometimes it may get changed. So that is depends upon the situation. Just we have discussed in the previous execution, we already seen that the address of the previously, rather address of memory allocation done by the calloc function gets changed when we allocate the memory again with the realloc function, but sometimes it may remain same. Look, again I am executing. Let me share the screen. So this is the previously allocated memory done by memory allocation, rather calloc function or malloc function. So now I am giving the value 11, 22, 33, 44, 55. Look, now the address remains same, but the previous execution the address gets changed. So it depends upon the situation, what will be the address of the newly allocated memory space. So thank you all. Thank you for your patience. We are concluding today's session. Thank you very much.